Is going to do a short talk on DNS analytics. You have the floor.
Thank you. Is this working?
Yeah.
Close.
It needs to be closed.
Thank you. Hi, my name is Osama. I work for QCert. It's the national CERT team in Qatar. And today I'm going to share with you our journey into DNS log analysis, our platform that we built, the design architecture, what we found, how we found the things that we will share with you, and the way forward. So this is how we show our customers that it's important to check your DNS logs. Actually, most of them, they don't have even the logs enabled at the beginning. And there are many reasons that malware are using DNS for different purposes. This is a couple of years old paper, but still valid, as we all know. So our approach is very simple. We go to the customers, we take the logs, we do some automated offline analysis, we verify the findings manually, and then we give them a report at the end. It's a very simple approach. Here's some numbers. We did this for more than 20 organizations. Some of them we did it for several times on regular basis, like on quarterly. And we have analyzed 600 million logs so far. And all of the organizations that we have seen, they have infection somewhere, all of them. So it's not a surprise, maybe for the community here, that everyone is infected somehow. We have relatively high false positives, but there are some reason for this, because we don't have any idea about the customer's network, what's in there, how they organize the things, what are the security devices in there, their proxy servers, the anti-spam, maybe there are some weird applications or the network they're behaving strangely. Like Google search engine, for example. I mean, this the kind of get the false positive high. So this is the network and design architecture for our system. It's all based on virtual environment and KVM. We're using Open vSwitch as a virtual switch, pfSense firewalls. We have different VLANs for logging for the applications, for the clusters that we have. And this is the system architecture that we have. When we designed this at the beginning, we have two goals. The first one is to be scalable as much as we can, because we are able to handle much more logs that we are handling now, and we don't want to change things. The second thing is the scalability and at the time. The time is very critical. I mean, we try to minimize the time as we can for the analysis. We start with the parsing. The parser will take the logs and directly index it in Elasticsearch cluster. While we index, we extract the second level domain and the domains from the logs, and we start the enrichment process. We get the dig, who is information, get the domain properties, like the domain length, the number of digits, sequences of the characters, things like that. And we go for we also tag the domains. If it's blacklisted, whitelisted, CDN looks like CDN or looks like an ad server. And then we store everything in a data store, which is Hypertable in our case, and we index everything again into Elasticsearch. At the end, we have a free-form API query that we can do whatever queries that we have to get the malicious activity that we need. The time is very critical for this. The case that we'll talk about, we took like 40 minutes to analyze the number of logs. This is very critical when in our setup, without metrics, without logs, we would be spending lots of time troubleshooting or getting the best out of the system. Thanks for Grafana. We have whois and dig workers. It's cloud-based. It's all automated. We fire up the workers, send the domains, get the enrichment data, shut down the instance, and get back the data. This costs like $5 per case, so it's very cost-effective. At any point in our system, we can export the data into JSON file. JSON, very flexible format. We can play with it and away from the system. We can put it on Graph database. I can put it on my Elasticsearch platform and without any problem. So this is the sample case that we will talk about. It's recently analyzed. We had like 72 million records for 14 days. And actually, in terms of logs, actually the data set that we are working with is like 20% only of this number. In terms of domains, from the 72 million records, we have like 14K unique domains out of it. So it's not bad to start with analyzing. And then we do the analysis. We get like 500 domains, and this 500 domains was one of the biggest cases that we have seen, like the number. Usually we have like hundreds, 100, 200 domains. So this case was 500. And then we do manual checks, and the manual checks is essential. I mean, we have to verify what's in there, and we do lots of things to minimize the time for the manual checks. We'll share with you what we do. And at the end, we found like 44 hosts infected in the network. This takes like 45 minutes for the automated part. The first thing we do, the trivial thing, we have blacklists. We have a separate platform for indexing more than 85 feeds every day, 500 megabytes on daily. That's a separate platform, parsed, indexed. It's used also for Elasticsearch. And the first thing is we check the domain. If it's in the blacklist, we tag it as blacklisted domain. We also tracking sinkholes. There are lots of talks about sinkholes a couple of days ago, and these days. So we try to track the sinkholes. Some companies try to hide their sinkholes, but we are trying to get them. So what we do is we check the domain. If it's pointing to a record, so this is sinkhole. If it's the name server, the authoritative name server of this domain is one of the name servers that on the screens, that's sinkhole domain. We also check for dynamic DNSs, and there are lots of reasons to check for dynamic DNS. As we can see that lots of threats are using heavily depending on dynamic DNS because of the flexibility and free and easy to set up. And for this specific case, we found this was on the blog for FireEye, and it was targeted attack against oil and gas companies. And it ended up that this attack was, these IPs were the remote access IPs for the company, and it ended up that it's the vendor support personnel there have infected machines. So this is kind of alarming thing. This is one thing we do, is the grouping the domains by a record. So when we visualize things, that you can figure out there's something weird here, something unusual. As you can see, most of them are in the same subnet almost, and we have like semantic typo here pointing. This could be parquet domains, could be a sinkhole, or I don't know. So this is the kind of thing that we report on our findings. We also group by name server, and this is what we found when you group by name servers. At the right side, this is the graph for the name servers. This is all for WordPress. This could be WordPress scan or DDoS attack, whatever. But this is what we found when you visualize. We get the top cold name servers, and we dig inside, and we found this. A couple of IPs are getting into these domains like hundreds of times every day, almost. So this is like something that need to be figured out. Keywords are very essential in our search. I mean, we search for specific keywords. We have a big list of keywords. We check on the domains, and we found and tag the domains that we found that this has some bad keywords. We have lots of rules. I mean, we do DGA search, midnight queries. We have found queries on off days, new domains that we have never seen before. We do fast flags detection, like checking the TTL values of the number of IPs for a specific domain, number of countries for these domains. So this kind of stuff, these are the rules that we check. The second part is we try to minimize the verification time. And to do this, this is one of the things that we do. We get the domains that's tagged as suspicious domains, and we graph it. This is a D3 graph. And when you look at the graph, you can figure out there's something interesting here. When you zoom in, as you can see, there is one host contacting a bunch of SU RU domains, which is alarming, and it appears that it's a botnet. And there's another host contacting malicious I mean the strange characters domains. So this is the kind that you can spot easily with the when you visualize the domains out of the automated things. We also have a Google custom search engine. We put like more than 300 security related websites. We check the domain, the analyst will get the domains and check it for if there's something related to these domains on someone else finds something on it. We also have a separate platform for manual verification. This is just an web interface for different APIs and different passive DNSs. This is not meant for bulk queries. This is just for one by one to not to abuse the APIs. When you put the domain here, you will get tags. Is it CDN? Is it blacklisted, whitelisted? It's an X domain. It's not there. We also go for virus total and check the number of URLs related to these domains and as identified as suspicious. And we get from the passive DNS, we get the IPs at the bottom and the IPs. And through virus total, again, we check the number of malicious URLs and downloaded samples that you can download. We get the whois, parse it, and the raw whois data. We get the dig. So for the analyst point of view, everything is on one interface. You can easily figure out if this is something that needs to put on the report or not. We also use OpenDNS API. We have lots of APIs behind this. This is not the updated version, but it gives you an idea what's going on. We also visit the website itself through a Tor connection. So we get all the source code, the HTML source code, redirections, scripts, iframes, and if there is a domain inside the web page itself, we go check it as well for virus total and the same process again for the domains inside the web page, so we can identify exactly what's going on. So for the effectiveness of what we have seen, I mean, I wish I could have a graph to show you how things, but the numbers are scattered in different reports, and this is still work in progress. Surprisingly, the blacklists are not the most efficient way to check for the malicious domains. That's this was a surprise for us because we were depending on blacklists at the beginning, but it's not effective at all. We pay a lot for blacklists here. We have some commercial, some free. We put lots of money for the blacklists, but it's not worth it. I mean, for this application, we do it for other. We have blacklists for other reasons. Sinkholes are number one indicators for what we have seen. Bad IP reputation, keywords, new domains. So these are sorted by the number of findings. And this is what we use in our system. I mean, this is all the APIs and technologies. Use collectd for the metrics, collectd influx for the metrics, and Grafana. Kafka for messaging, messaging pipe, Elasticsearch, Neo4j for the graph database. We did not yet play much with graph database, but this is on our next efforts. And we have the Greylog 2 for as a syslog server, D3 for graphing things. We have APIs to number of passive DNSs and commercial services as well to help us in our setup. So what's next in our setup? We are working to minimize the manual analysis, and still this is a work in progress. I mean, even if it's a work in progress, we have found lots of things, stuff. It's very successful. I mean, the customers are happy. We're finding something on them. We will work hard on visualization. We did not, even if we are not doing some complex classifiers or machine learning algorithms, we were able to find something. And this is our next step, hopefully. So, the last thing is, we think that this setup can be scaled to the enterprise. We can copy the same setup into the enterprise and could be helpful for them. So either by having the same setup, exactly the same setup on their network, or just give them an API or some way of getting the data out of our things. So I have to give the credit for the team, and that's it. Short presentation. Thank you.